Hi all, today we are going to discuss about the need and applications of the DC choppers followed by different control strategies that are employed in practice. So many industrial applications need DC power for working of those drives. The reason is when compared to the AC drives, DC drive speed control is much more easy and flexible. That's why practically most of the industrial drives operates on DC power. And also in some cases it is required that the DC source voltage should be at some different voltage level compared to the input voltage level. Like for example, if you see your computer, so different equipment in your computer need different voltage level. So there we go for the SMPS and these type of devices where we have need different DC voltages, and sometimes we need a variable DC supply to control the speed. The examples are subway cars, trolleys, buses, battery operated vehicles. So in all these applications what we need, from a constant DC input voltage, I need a variable DC output voltage. That means this V2 should be variable so that I can connect to my drive, I can do the adjustable speed. That means by varying the armature control of any motor, we can control the speed. So for that we need a variable voltage. So this can be obtained by using either resistance controller, motor generator set, or we can go for the inverter rectifier set, or finally we can go for the DC chopper also. Let us see each one of them. So first one, starting with the resistance controller. This is the conventional technique. This thing we have discussed while discussing DC motors also, speed control of DC motors. So how we can control this, any drive or anything. So this is my input voltage. So connect one series resistance in series with the system, and you have to remember that the current capacity of these resistors should be same as the current carrying capacity of your drive. So that's why this resistor is little bit costly, and this resistor we need a variable resistor. So by varying this resistance, we can control how much voltage drop is dropped across this resistor. Remaining voltage V2 will come at your load. Let us take for example, if I am assuming the current that is going to the load is I0, so the voltage drop across this resistor, this voltage drop across this resistor, so this will be equal to I0 multiplied by R. So accordingly this V2 will be equal to V1 minus VR. So this much voltage will come to your load. So by this we can flexibly control this, how much value of the voltage comes. It is very simple, but the disadvantage is as we are involving a resistor here, so in this resistor there will be continuous power loss. There will be a continuous power loss which is equal to I0 square into R. Continuous power loss is there as the value of current is very high for the drive, so continuous power loss will be there. So efficiency will be very less, so that's why this is not preferred in practice. Then second type of application is by going for the Ward-Leonard method or using a motor generator set. So in this case what we will do, this fixed supply voltage, this is given to a motor. So by controlling the field control of this motor, we can control the speed of the rotor. So this rotor is coupled, mechanically coupled to a generator. So this generator again, we can control the field. By controlling the field and the speed of this shaft, we can control the how much EMF is generated by this generator. So the generated voltage will be given to our load or the drive. That means by controlling the field control, we can easily control the voltage that is supplied to the load. But the disadvantage of this one, because this generator has to supply the total load, so the rating of this generator, because this is again driven by this motor, so this generator as well as motor rating should be greater than or equal to rating of your drive. That means the cost becomes 3 times. And the second disadvantage is so many steps are involved, because 2 steps are there. First, electrical energy is converted to mechanical energy, then mechanical to electrical, then supplied. So during the energy conversion, the efficiency losses will be very high. And second one, the size also increases drastically. That means I am summarizing that this needs 3 machines of same rating. So cost increases drastically. The losses are high because you are converting electrical to mechanical and mechanical to electrical again. And the third one, it is very bulky and slow response due to the time constant of the field. So when you vary the field, immediately the voltage will not change that much fast. So slow response when compared to other methods. So that's why this method also not used in practice. So the third method that can be gone is using an inverter followed by a rectifier, because we have a device in the alternating current, that is the transformer. Using transformer, I can flexibly control my output voltage. You can step up or step down. So in order to use the transformer, my supply should be AC, but actually our supply is DC. So this DC is first converted using an inverter to the AC. Then we use a transformer to step up or step down the voltage depending on our requirement. Then that output, that AC, is again rectified or converted to DC, that DC will be supplied to load. So here again 3 stages are involved. First it needs one inverter, then one transformer, either step up or step down transformer, then one rectifier is required to supply the required voltage. So again in this case, because multiple stages are involved, so the cost increases and it is a bulky also, and third one, as multiple conversions are there, so automatically efficiency will be less in this case. But only one advantage of this method is this transformer will provide the isolation between this load and the source, except that remaining all are disadvantages. So this one is also not used in practice nowadays. It used to be used in olden days. So what is the best option to go? We can go for directly for DC-DC converter, which is also called as a DC chopper. So this basically employs the static devices to convert this fixed input voltage to a variable DC output voltage only with one stage conversion. Directly it uses the one stage conversion, and it uses the simple static devices whose efficiency is very high. So as a result of this, it will have very high efficiency, smooth operation is possible, and that too very fast response is possible, and cost is less and the maintenance is also less. Even along with that, even regeneration is also possible. Regenerative braking also can be used. So whenever your machine you are applying the brake, that can be used, that energy can be used for generating the power and supply back to the source. So that is also possible using DC-DC converters. So what are the applications of these DC-DC converters? These can be used for speed control of DC motor in battery operated vehicles, electric cars, subway cars, trolley cars, hoists, etc. So what they employ for doing the switching operations, generally they use the high speed on off switches, because you have to turn on and turn off. We are going to discuss this entire thing in detail. So for doing this turn on and turn off, that means the high speed operation, we generally go for the power transistor for low and medium power applications, and we go for forced commutator thyristor. That means externally commutated thyristors are used for high power applications. So let us take an example to understand the concept of DC-DC chopper, why it is called as a chopper. So chopper, what basically it do the chopping operation. Chopping means cutting. It cuts your input voltage, because we know your input DC voltage will be like this. Your input is a constant value. This is having a voltage of Vs. So this is my value of the supply voltage. So this supply voltage, what we will do using this switch can be any of the devices that are discussed above. So I am assuming this switch is the ideal switch to make the analysis easy. So this switch will be connected to the load. Let us take for example the load is the RL load. The voltage across the load I am representing by V0, and the current passing through the load I am representing by I0, and across this load one freewheeling diode will be connected in anti-parallel. So this freewheeling diode is used for continuous conduction even when the switch is turned off. So let us see how this will operate. So what we will do, first I will close the switch. When the switch is closed, what will happen? This entire voltage will apply across your load. That means your output voltage will be equal to supply voltage. You can see when the switch is closed, output voltage will be equal to the input voltage. This is equal to Vs. Output voltage is equal to input voltage. So now when you open the switch, what happens? This is open. So your supply voltage is not going here. So now this current is passing like this. This current will continue to pass through this diode, because now diode will be forward biased, because this inductor will not allow the sudden change in the current. So this will pass through the diode. So through the diode it is closed. So ideal diode, the voltage drop across the diode is equal to 0 volts, or we can tell the output voltage will become equal to 0. When the switch is turned off, the output voltage is equal to 0. So during this time what happens? Whatever energy is stored in your load, that is used for circulation of the current. So obviously the current will start passing. I am repeating once again. So when the switch is closed, the current will start increasing, because your entire supply voltage is connected to your load. So your current will, because inductor will not allow the sudden change, so gradually the current will goes on increasing. So let us assume after some time t on, we are turning off this switch. When you turn off the switch, the energy stored in this load will be dissipated. So gradually your I0 will goes on decaying. Again after some time we will turn on, again it will increase and turn off. So in this manner it will operate. So using this you can see as the output voltage is chopped or cut. So that's why it is called as a chopper. So if you want to calculate the average output voltage will be equal to T on, because out of the total duration T, it is on for only T on duration. So average value will be equal to T on divided by T on plus 2 off, or nothing but the total time multiplied by your supply voltage Vs. Or this I can write as T on by T times of Vs. This is T on by T. This is called as the alpha. So alpha multiplied by Vs. What is this alpha? Alpha is T on by T. This is called as the duty cycle. Here T is the chopping period, T on is the on time, and T off is the off time of this thyristor switch. I think it is clear to you. So now I can rewrite this. I can write my average output voltage is equal to T on by T times of supply voltage. What is this T on? I am separating 1 by T, 1 by time period or 1 by chopping period, that I can call as the frequency. That means chopping frequency or the frequency of this switching circuit. So this is the 1 by time period. This gives your frequency. So this I can write as frequency multiplied by T on multiplied by Vs. So how can I control the average output voltage? Because input voltage Vs is constant. So here the variable are T on and the frequency. Either by controlling the switching frequency or by controlling the on time, we can easily control the output voltage. So depending on how you are varying these things, so there are different type of control strategies they are available. So different type of control strategies. The first one is the time ratio control. So in the time ratio control, the ratio of T on by T, which is nothing but the alpha, is varied by varying. How we can vary alpha? Because it is a ratio of T on by T, either I can vary the on time or I can vary the total time period or I can vary the frequency. So depending on that how you are varying, there are two types of strategies in this time ratio control. First one is I maintain the time constant, or 1 by T is nothing but the frequency. So I am maintaining the frequency constant, which is varied, T on is varied. So T is maintained constant and the on period is varied. So this means you can see here, this is my on period, this is my off period. For this much time it is on, this much time it is off. So total duration will be maintained constant. You can see total duration is maintained constant, but on period if it is decreased, so the total time for it is on is decreased, then what will happen? Average output voltage will decrease. Similarly, by increasing the on time, by keeping the total time period constant, what will happen? Average output voltage will increase. That means by controlling the on period how much, we can easily control my output voltage. So this variation of the T on is nothing but adjustment of the pulse width. How much width of the pulse is given? Total time T is constant. What is the width of this pulse? The on pulse. The pulse is adjusted. So as you are adjusting the pulse width, so it is also called as pulse width modulation scheme. So this is also called as a PWM, pulse width modulation scheme. So this is most commonly used method compared to other methods. The reason we are going to discuss in the coming sections. So then the second type is possible variable frequency system. That means it is also called as a frequency modulation. So in this case, the time period T is varied by keeping the T on or T off constant. So this on period or the off period can be constant, but the total time period is varied. Let us take for example, I am maintaining the T on constant and varying the total time period. So total time period is this. Initially, let us assume this is my on period. So some average voltage is there. Now if the total time period is decreased, that means if the frequency is increased, what will happen to the output voltage? You can see here this average output voltage is increased in this case. Similarly, if you are increasing the total time period, average output voltage will decrease. So by controlling the frequency of your switching frequency, we can easily control the output voltage. So this is one way. Second way is maintain the off time constant. We are maintaining the off time constant. So in this case, what is happening? T on is constant. So which is varied? This off period is varied. How much time this thyristor is turned off, that is varied. So that's why total time period is varied. Second way is keep the off time constant, vary the on period. Keep the off time constant, vary the on period. So in this case, what happens? This turn off time is constant and the on time period we will vary. So initially, let us assume this is the width. So automatically some average value is there. So if you are decreasing the on period, off period is maintained constant, on period is decreased. So in this case, what will happen to the average output voltage? Average output voltage is decreased. If you want to increase the average voltage, you have to increase the on period time. So using this, we can control it. So here T off is maintained constant. But this method is having some disadvantages. So the disadvantage of frequency modulation is, as the chopping frequency has to be varied over a wide range to get the variable output voltage. In both the cases, you can see total time period is changed. That means frequency is changed. So wide variation of this frequency is required to get the variable output voltage. So as the voltage variations are, frequency variations are more, so automatically the filter design for wide variation of the frequency will be quite difficult. We have to design a filter for wide variation of the frequency will be quite difficult. And second one, as it can operate at very high frequencies, so because of this high frequency operation, there is a possibility of interference with the signaling and telephone lines. That is the second disadvantage. So let us take for example, you are maintaining the on time constant and varying the total time period. In that case, the off time is continuously variable. So if the off time is very high, so when the off time is very high, what will happen? That continuous conduction of the current may not be possible. The current may become equal to 0. Let us take for example, I am just going above so that I can explain you this one. So you can see here, for this off time period, the current is dropping. If the off time period is more, then what will happen? This current may reach 0 and for some time there can be discontinuous conduction may be possible. That is a disadvantage. So because of these disadvantages, so this frequency method is not used in practice. Only we go for the pulse width modulation. Frequency modulation is not used. There is one more method. So that is the current limit control method. Let us see what is the disadvantage of this. So the name itself is telling current limit. We will decide what will be the limit of the minimum value of the current and maximum value of the current of the load that is passing through the load. So we have to vary between these two limits only. Current should not go above or below. So accordingly, we will control the on time and the off time of the thyristor. So here T on and T off are controlled by the maximum and minimum values of the load current which are fixed, pre-decided. So when the current reaches the I0 maximum value, the thyristor is turned off until it reaches the I0 minimum value. You can see the current is increasing. When it reaches the maximum value, thyristor is turned off until it reaches minimum. Again, it will increase. So in order to turn on and turn off based on this, we need a sensor. That sensor will detect whether the minimum current and the maximum current are reached. Accordingly, it takes the action. So because of this, the control strategy needs some sensors. So because of this, it needs a feedback loop. So the triggering circuitry is more complex when compared to other methods. That is the first disadvantage. And the second one, as the current is varying, we can represent by a term called as a ripple current. Ripple current is the difference between maximum current and the minimum current. So this is the difference between these two. So practically, I want my ripple current or the ripple in the output current should be as minimum as possible. So if you want to decrease this ripple current, what will happen? The turn on and turn off time will be very small. So frequently we have to turn on and turn off. Frequently we have to turn on and turn off, or otherwise we can tell that to decrease this ripple current we need high switching frequencies. When you need the high frequencies, every time during the switching there will be switching losses. So more switching losses will be there. That is another disadvantage. So that is the reason even this method also not used in practice. So practically we always go for PWM technique only for turning on and turning off the thyristors. I hope that up to here the basics of the choppers, what is the need and applications, and why only PWM is used is clear to you. If you still have any queries, you can leave your comments in the comment section below. I will answer to your queries from there. Thank you. Thank you very much.